This comes from chapter 9.1, correlation. And the first thing I want to tell you is that it would really benefit you if you would get a graphing calculator to work these problems. It's just so much easier to work it with a graphing calculator. But anyway, this is about movie budgets and grosses. The budget in millions of dollars and the worldwide gross in millions of dollars for 8 of the most expensive movies ever made are going to be shown in this table that we're going to look at. This is the table. And this was the budget in millions of dollars, and this is how much money they grossed on it. So the x-axis is going to be your budget in millions of dollars, and the y-axis is going to be your gross amount that was grossed on it. Here's what you're asked to do. Display the data in a scatter plot, calculate the correlation coefficient, and make a conclusion about the type of correlation. So I'm going to move down first and show you the graph. Then we'll come back to what I have typed here. Alright, here's the graph, and I just kind of sketched it out. And this is the budget on the x-axis. And remember, your budget went from 170 up to 210, or up to 207, which was close to 210, and then the amount you grossed on it. So you would just, this is a scatter plot when you just graph them, and they're just kind of points scattered everywhere. And now what you would do, and I'm going to take you to Tools for Success with the calculator. You would go to Tools for Success with the calculator, and here's where I want to be. And if you would go to this part, Tools for Success, and Chapter 9.1 Correlation, these are the examples that are in the book. It tells you what page they're on, and it works them out. And it will do a scatter plot for you. You use L1 and L2. And you put your numbers in there, and this tells you exactly how to get to the scatter plot, and it will make a scatter plot for you. And it says that this one shows a positive correlation, and we'll go back and talk about the correlation on those others in just a minute. What I want to show you here is that that correlation coefficient formula is just tremendous. But if you will do this, if you will use the calculator and you go back into stat, you put your numbers in L1 and L2, you leave the same ones that were in there from the table that you have, and right here it gives you the correlation coefficient. You don't have to do all those square roots and all that stuff. And so, you know, that's what you want to learn to do, is get the use the technology as much as you can. But anyway, it shows you all the different examples of how you do these problems. Number 23 is actually done in here, and number 33, number 5, and number 3. This is in the, it tells you what page it's on and everything. So now we're going to go back to the problem, because I only have 5 minutes that I can record in, so I don't want to use all my time doing that. So you would use the calculator or that enormous formula, and you would find that R is equal to 0.427. And what you want to do here is you want to look at this. So when you find R, you look at the range of the correlation coefficient, and it's supposed to be between -1 and +1. If X and Y have a strong positive linear correlation, you're going to find out that R is close to 1. If X and Y have a strong negative correlation, you're going to find out that R is close to -1. And if there's no linear correlation or a weak linear correlation, R will be close to 0. Now it's important to remember that R is might be close to 0, but it does not mean that there's no relationship. There's just no linear relationship. So here you have a weak positive linear relationship. It is positive because it's 0.42, but it's weak because it's not anywhere close to 1. It's halfway from 0 to 1. So that's why it would be that. But I suggest you get a calculator and you use it. You'll save yourself so much time.